So now, so now we will look into cluster analysis and provide the basic understanding of cluster analysis and how can we implement cluster analysis using procedures in SAS. So now the objective of cluster analysis. So basically we want to find the groups of objects such that these objects in this group, they are similar to one another and they are different to objects in another group. So cluster analysis has some applications. So for example, the businesses, they collect large amount of data on current or potential customers. So clustering can be used when it's come to segment customers in smaller number of groups for additional analysis and also for marketing activities. So this is just one example of how cluster analysis can be used when it's come to customer segmentation. Now, cluster analysis has, so we have different types of clustering. The one and the most famous being K-means. So K-means, it determines K clusters based on Euclidean distances. So what we should know when it comes to K-means is that it requires the expected number of clusters from the beginning. So that is one of the drawbacks of K-means, is that we have to specify the expected number of clusters from the beginning. So let us understand the basic K-means algorithm. So when it comes to K-means, it select K points as initial centroid. I will do some visualization of this algorithm. So it select K points as initial centroids. Then it repeats this same procedure. So from K clusters, it forms K clusters by assigning each point to its closest centroid. And then it recomputes the centroid of each cluster until the centroids do not change. So you might be asking yourself, what is the centroid? Well, a centroid is best thought of as an approximated center of a given cluster at any given time. So when it comes to K-means algorithm, there are K clusters, and so we should have K centroids. So a centroid, as I did mention, we can thought of it as a reference point to a given cluster, right? Now, let's understand how K-means algorithm works in a simple demonstration. So now, points, they are assigned to initial centroids, which are in the larger group of points. Then these points, they are assigned to the updated centroid, and centroids, they updated again. So if we can look from the second to the fourth diagram here, is that the centroids, they are starting to move into the groups of points. So initially they were here and now they are starting to move. So the K-means will then terminate when there are no more changes that are occurring, which means that the centroid have identified the natural grouping of the points. So to assign points, we use Euclidean distances. Also, Manhattan and Chakra distances can be used, but we will look into stars and explain how we can use Euclidean distances. Now, we have another type of clustering which is called agglomerative hierarchical clustering. So, this type of clustering is just start with individual points as clusters and then it merges the two closest clusters until one cluster remains. So we will demonstrate how can we actually perform hierarchical clustering and be able to interpret this diagram here. So this diagram here is called a dendrogram. So we will also be interpreting a dendrogram. SAS provides us with cluster procedure. So Cluster procedure is for hierarchically clusters. However, we can specify method as our option. So where we can specify the clustering method. And also we will make use of the var statement, which will list the numeric variables that we want to use in the cluster analysis. So now is the time to see how all of this is done using SAS.